Okay, so today we are going to tackle the different types of events that we get in probability. Now, just for those who are new and who are joining us today, you can watch our recordings of the previous lessons. They are all on the website. So make sure that you head on over and watch anything that you might have missed or want to catch up on, and the quizzes are there as well. So there's really, everything's there. Everything you need is all there. Hi Bentley and hi Bokamuso. You guys are right on time for us to start with mutually exclusive events. Right, so let's think about this and be ready to pop answers in the chat, right? So you randomly select a single card from a pack of playing cards. Now, we all know what cards look like, and we've got black cards and red cards, and we have diamonds and clubs and hearts and spades. So tell me, can a card be red and black at the same time? Pop it in the chat. Can it be red and black at the same time? Okay, Watobians know their cards, which is good, because then you know that that is not possible. Nope, it is impossible. It can either be red or black. And can it be black and a 10 at the same time? Can it be black and a 10 at the same time? Yes, we can have a black and a 10. We can have the 10 of spades and the 10 of clubs. Those are all black and. So they are, those things can happen at the same time. Okay. And can it be a king and a queen at the same time? No, it cannot. Definitely not. Okay. So this first example that we used with the cards and this third one, question A and question C, we say that those two things, because they cannot happen at the same time, those things are mutually exclusive. So that's just a big word to say that these things cannot happen at the same time. Simple examples from your own life. You cannot be at home and at school at the same time. You cannot be riding your bicycle and walking at the same time. Those things are all mutually exclusive. So maybe, can anyone think of another example just from your own life of mutually exclusive events? Just pop it in the chat if you can think of anything from your own life, like riding your bike and walking, being at home and at school. Those are all mutually exclusive. Pop in the chat if you can think of another example from your own life. Yes, that's right. Bath and be dry. Be awake and asleep. Night and day. Well done. Good stuff. Yeah, you guys get it. You guys get it. Okay, well done. So we can represent these on, we can represent mutually exclusive events on Venn diagrams. So if things are mutually exclusive because they cannot happen at the same time, we picture them in a Venn diagram as two separate circles. So if it's event A and event B, then it is just the two separate circles and there's no overlap. Now, if it is not mutually exclusive, like the black card and the 10 happening at the same time, those two things can happen at the same time and they're not mutually exclusive. So for that, we picture it in the Venn diagram with the two circles intersecting, and you'll remember from last week that we did work with this where there was intersection between two events if they overlap. So we can say that in the first block for mutually exclusive events, we just have A or B, and that's just going to be A and B. But if we look at A and B, where they are not mutually exclusive, when they actually overlap, Then we're going to say A plus B, and we are going to subtract the overlap because we cannot count that twice. All right. Yes, Bokamusa's got a question. Let's hear it.
Hi, ma'am.
Hi there.
Ma'am, I wanted to ask, ma'am. So that U sign, last week, ma'am said that the U sign means union. It's therefore union. So
Yeah.
then why did we make use of it there by the first Venn diagram? Why did we make use of it where there's two, where there's no overlap, meaning there's no connection? If I can.
Because remember, the U means A or B. So it can still be A or it can be B. It just can't be the two of them together at the same time. So so for this first one, we can't use the intersection sign at all because we can't do that because they don't overlap. So the only way that we can show it is the A union B. So that still means A or B. It can still be A or B. And then if we go to the next picture where it's not mutually exclusive, where they do actually overlap, if we look at A or B, then we are still going to say A or B, but we need to just take out the overlap if we just want to look at what A or B is.
Okay, making sense. Thank you.
Okay. Right, so the first rule we're going to learn this evening, or that you should have learned if you have done probability in school already, is this addition rule of probability. So that just basically says, if you have the probability of A or B happening, then you take the probability of A, add the probability of B to it, and this is meant to be a minus, and subtract the probability of A and B. But when we work with mutually exclusive events, the probability of A and B is equal to 0. And just think back of that example with the card and all of the ones that you guys just gave, because the two things cannot happen together. So the probability of A and B must equal 0. Right, so let's see how we're going to do this in an actual question and how it gets asked. So the first question says, the probability of A is 3/10, and the probability of B is equal to 1/2, and are mutually exclusive. Okay, so what do we know? We know that the probability of A and B for mutually exclusive events must equal 0 because there is no overlap. So what is the probability of A or B? Remember, the U sign means or. Now for that, we are going to use our addition rule to calculate this. So have a look how we do this. So our addition rule, remember, is this one here. So we say the probability of A or B, probability of A or B is the probability of A. The probability of A we got over here, that's 3/10, plus the probability of B, we got that over here, that's 1/2, minus the probability of A and B. But because these are mutually exclusive, that means the probability of A and B is equal to 0. And that you can just pop into your calculator and put it in the chat for me when you have worked it out. Bayanda was quick with that. Let's get the other Watobians on board as well. Our first sum for the evening. Rightio, so that is 4/5. Now let's see who's been listening and paying attention and understands. This means the probability of A and B. No problem, Inam. Who can tell me what is the probability of A and B? Remember, the events are mutually exclusive. So what is the probability of A and B? We just worked out the probability of A or B. That was 4/5. So what is the probability of A and B? Nice, that's right. Good stuff, guys. Yeah, it's 0. The events are mutually exclusive. So the probability of A and B is a big round 0. Okay. Okay, right. Let's practice some more. And now we're going to do it with a Venn diagram. So I'm going to give you some time again to read. And veteran Watobians will know what we do is post that emoji when we are done reading. Okay, so have a read through the question and then post your glasses emoji when you are done. I'm going to keep quiet so that you can concentrate. Okay, while people are reading, we're going to give Pendile a chance to ask a question. Hi, Pendile.
Hi, ma'am.
Hi there.
For question 2, I want to know, how do we get 0? Could you please explain?
Okay, so for mutually exclusive events, they cannot occur at the same time. So the probability of A and B is 0. That's why.
Oh,
So it says there at the start of the question that the events are mutually exclusive. So then immediately we must know that the probability of A and B equals 0.
Thank you.
Okay. Okay, let's see. Sorry, I did scroll away from the... Okay, let's see some more emoji faces. If you're done reading, please post. And remember, Watobians, our ground rule of participating. So we are about 100 strong already in the class. So I want to see 100 of those little glasses faces when you are done reading. Okay. So let's see. At a fast food outlet, 75 people were surveyed to find out what food they had eaten. 23 had eaten burgers, 30 had eaten fried chicken, and 7 had eaten both. So, are these mutually exclusive? Pop in the chat your answer. Are they mutually exclusive or not? No, they're not. They're not mutually exclusive. Well done. Because it says here 7 people had eaten both, meaning had eaten both burgers and fried chicken. Okay, so calculate the number of people interviewed who had eaten neither fried chicken nor burgers. So those who had eaten nothing. How many people will that be? Pop it in the chat if you figured it out. We are using what we learned again about Venn diagrams. Is it 15? I wonder if there's someone who wants to volunteer to answer the question. Put your hand up if you want to volunteer. How you got 15? Masego.
Ma'am, I'm not really sure, but I took since the total amount of people was 75, I took the other numbers, which was 23 who had eaten burgers, 30 who had eaten fried chicken, and the 7 that had eaten both, and I added them, and they all gave me 15. Was it 15? not really sure, ma'am. Let me just quickly check.
Okay. Okay. So maybe it's easier if we first draw the Venn diagram for this.
Yes, ma'am. It gave me
Yeah.
60, and then so I just said 75 minus 60, which gave me 15.
Okay. Now, what we must remember from Tuesday's lesson was that these people, the 75 people, there's 23 who had eaten burgers and the 30 who had eaten fried chicken. Those include the 7 who had eaten both. Okay, so that's why I think maybe if we draw the Venn diagram first, then we'll be able to calculate more clearly how many ate nothing. Okay, so I want everyone to now do your Venn diagram. So we've got burgers and we've got fried chicken. So quickly draw your Venn diagram and remember there's overlap. And I think once we've all drawn this Venn diagram, we'll see what the answer is, what the correct answer is. $75 people altogether, burgers and fries. Remember from Tuesday, we always start with the overlap first. So the overlap is in the middle, those who had eaten both burgers and fried chicken. So put that down first and then do the rest. I'm going to give you a minute to do your Venn diagram and to figure out how many people had eaten neither fried chicken nor burgers. I can only say that the answer is not 15. It's not 21 either. I think I'm just giving everyone a chance still, guys. Just giving everyone a chance to think. Okay, let's have a look, everyone. So the 7 are those who ate both. Now, altogether, 23 people ate burgers. And if you remember from last week, Thursday's lesson, we cannot double count the 7 who ate both burgers and chicken. So from the 23 include those people who ate both. So we have to subtract from the 23 the 7. So to get burgers only, we'd go 23 minus 7. So burgers only, I'm going to write it here. 23 minus 7 gives me 16. Okay, make sure you understand. The golden rule is to always start with the intersection. And the intersection is where the overlap is, the people who ate both. So how many people ate fried chicken only? Let's see who's been paying attention. 30 ate fried chicken, but 7 ate both, remember? So we subtract that. That's right, 23. Okay, and now how many people ate neither fried chicken nor burgers? We're going to say 75 minus 16 minus 7 minus 23, and that's going to give you the number outside of the circles. So 75 minus 60 minus 7 minus 23. That is golden number 29. We use the 75, remember? Okay, so that's 29, and there's our Venn diagram. Okay, so determine NS, where S is the sample set. Our sample set, that's quite easy, that's 75. Now calculate the probability that one of these people selected at random had eaten neither burgers nor fried chicken. Okay, you guys do that while I answer Denayo's question. And pop it in the chat when you're done. Denayo?
Hi, ma'am.
Hi.
I don't understand how we got 16 for burgers. Cause like
20,
why did we minus it? I don't understand that.
because 23 people ate burgers, but 7 of those people ate burgers and fried chicken. So that's why we always start with the Venn diagram with the overlap, with the 7 people who had eaten both. And then we do the same for the fried chicken. Yeah.
Oh, okay. I think I get
So
it
that
now.
we get the number of people who only ate burgers.
Was it not 23?
No, so the 23 include the number of people who ate both.
Oh, okay. I get it now. Thank
Okay.
you.
Okay, it's in Tswalu. The 29 comes from going 75, which is our total, minus 16, minus 7, minus 23. That gives us 29. That's the number of people who ate nothing. Neither chicken, neither burger. Okay, guys, I'm waiting for the answer for question E. What is the probability that one of these people selected at random had eaten neither burgers nor fried chicken? Come, we've just worked out how many, so the probability is quite easy from here on. We can do that. Pop it in the chat. When you've done it, we want a percentage. So you are going to need to times your fraction by 100. The probability that one of these people selected at random had eaten neither burgers nor fried chicken. We just worked out how many people in question B had eaten neither fried chicken nor burgers. So we can calculate the probability. Let's get more answers. We must round to the nearest whole number. Read the instructions carefully, guys. Nearest whole number. Whole number. Okay, so we go 29 divided by 75 times by 100. That gives me 38.66 lots of dots percent, but we need to round to the nearest whole number. The nearest whole number here is going to be 39%. Good, well done, Masejo. Everyone else who got 39 says Shaba, Anyasha, Kanya. I spot a few people who got the 39. Well done. Okay, so that's mutually exclusive events, burgers and fried chicken. Now you know. If you eat both, you subtract it from the total, okay? Just like we did on Thursday. Okay, so that's mutually exclusive. Now, the other type of event you need to know is complementary events. So complementary events cannot occur at the same time, just like mutually exclusive events, but their probabilities together add up to 1. So it's only those 2 events, and together their probabilities add up to 1. So this is our rule for complementary events. the probability of A plus the probability of not A must equal 1. So here are examples of complementary events. Speaking English in everyday conversation and not speaking English. Okay, so it's as easy as that. Walking to school and not walking to school. Tossing a coin and getting heads and not getting a head. Rolling a fair dice and scoring a 3 or not scoring a 3. Okay, so those are all complementary. The important part is that, yes, they don't occur at the same time, but their probabilities together add up to 1. So let's see. The probability that a grade 10 learner chosen at random will pass English is 80%. What is the probability that this learner will not pass English? Let's see who understood. Pop it in the chat if you know. If the probability of passing is 80%, what is the probability of not passing? Fortune says it's 20. What does everyone else say? Let's hear, let's see. Pop it in the chat. Yeah, guys, it's 20%. The probability of not passing and the probability of passing, those are complementary events. So that is 20%. Okay, here's another one. Try again. The probability of getting a white ball from a bag of balls is 1/4. What is the probability of not getting a white ball? That's it. Yeah, you see. It's 3/4. So the two probabilities together must make 1 if they're complementary events. It's the one and the one thing and then not that thing. And together it adds up to 1. Okay, last one. A bag contains red and blue cards. The probability of taking a red card is 2/5. What is the probability of taking a blue card? Pop it in the chat. 3/5. Let me just see some questions. Okay, let me go back to question 1. So if the probability of passing English is 80%, what is the probability that you will not pass English? It must be 20 because 80% plus 20% gives me 100%. And if they are complementary, like we said over here, the probability of that event plus the probability of not that event must equal 1. Let's see. Anything else? Did I miss anything else, Ms. Coco? Okay, and then
it's just, I think they're having a problem with the difference between the 100% and then the fractions. I think there's a bit of a disconnect.
Guys, 1 is the same as 100%. So if we've got percentages, then that and all the probabilities must add up to 1, then 1 is 100%. How do we get 3/4? We go 1 minus 1/4 gives us 3/4. And then the last one, if the probability of taking a red card is 2/5, what is the probability of taking a blue card? So the events are complementary. So we say 1 minus 2/5 gives us 3/5. Okay. B. Okay, so I've explained B. You just take 1 and you subtract the probability from it to get the event that it's not. I don't understand B. How did you get 3/4? Guys, I just explained. Please follow along. I just explained that you go 1 minus 1/4. That gives you 3/4. Mokoko Bale, you have a question?
Hi, ma'am.
Hi there.
Ma'am, I just wanted to ask, right, for the complementary events, you have to have 2 mutually exclusive And so I don't understand how 80 and 20 are on the same trial, because I still don't understand that 100 how it comes through as 20, ma'am.
Ms. Kaka, can you maybe explain? Because I'm not sure. I've explained it now a few times, so
I'll
maybe you give it a
I'll
try.
explain in the chat, Mokobale, don't worry.
Okay, Mokoko Bali, Ms. Kaka is gonna help you. Tintwalu, you have a question, Tintwalu?
Yes, ma'am.
Yeah.
Ma'am, I was wondering why do we minus it? Like,
Okay, because the two together, do you see what I wrote in pink? The
yes, ma'am.
probability of the two events added together must give you 1. So if you have the value of the one event, then you subtract it from 1 to get the value of the other event, because together they must add up to 1. You're just checking what two numbers together is going to give you 1.
Oh, I see. I understand, ma'am. Thank you, ma'am.
Yeah. How is it the 20% if the answer is 100? Because 100%, the two events together, their probability is 100%. So if the one probability is 80 and the events are complementary, then the two together must add up to 100. So if the one is 80, then the other must be 20 to give you 100. Okay, that's just an example with percentages. Remember, we can express probabilities with fractions, decimals, and percentages. Okay. Right, let's do another one and then you can try again. So out of a group of 27 girls, let's read and then you pop your reading face in the chat once you're done. Yes, thanks, Siatemba. That makes sense. You get 20% to get 100. So if one thing is 80%, then the other thing must be 20 to get 100. Right, let's read and then you pop your glasses face in the chat when you're done. Okay, let's see. So out of a group of 27 girls, 10 play netball and the rest do not play netball. Okay, so if 27 play netball and if 27 girls, out of 27 girls, 10 play netball, how many do not play netball? Please pop it in the chat if you know. There we go. You see, we just added together 17. So 10 play netball, 17 do not play netball. Now, let's put this in a Venn diagram. I'm going to give you a minute to do that. Just make sure, is playing netball and not playing netball, can those two things happen at the same time? Can you play netball and not play netball at the same time? No. Okay. So make sure you draw your Venn diagram without circles overlapping. Okay, do question B. You've got a minute to quickly do that. Okay, so I hope you've got a good attempt there for your Venn diagram. Check that yours is right. So we've got our sample space, and that's obviously the group of 27 girls playing netball. Then we've got those who, or just the group of 27 girls, those who play netball, that's N, and that's 10. And then those who do not play netball, which we can just say do not, DN, or something else, whatever you chose to represent, do not play netball, and that is 17. Now, are these events complementary? Complementary meaning that you do the one or you do the other, okay? They cannot happen at the same time, and you only have those two choices. So are they complementary? Yes, Sakile, they are complementary. They're almost definitely complementary, yeah. If we had intersection between two events, then they cannot be complementary. Okay, so they are definitely complementary, yes. And then question D asks, determine NS where S is the sample set. So our sample set is the 27 girls in the group that we are looking at. Okay, it can only be 27. And then let's do the probabilities in the last question. One of the 27 girls is chosen at random. Determine the probability as a common fraction that the chosen girl plays netball and that the chosen girl does not play netball. Okay, while everyone works on that, let's hear from Lucanio. Lucanio's got a question. Ask your question, Lucanio.
Excuse me, ma'am.
Yeah.
Ma'am, is it an event if they do not play anything?
If they do not play anything, in this example, everyone either play netball or they don't play netball. So not playing netball is an event.
Network.
Pardon?
Okay. I hope, Lucan, you got that. So the chosen girls play netball, that's 10 out of 27. And then the chosen girl does not play netball, that is 17 out of 27. Now let's look, guys. The probability of playing netball. So the probability of playing netball plus the probability of not playing netball. What does that add up to? I have 10 over 27 plus 17 over 27. What does that give me? It gives me a nice big 1, which is also 100%. Okay, all the same thing. Right, I think that's all we have time for this evening. Ms. Coco, do you have a poll that you would like them to do?
Yes, I do. Okay, guys. There's a poll on your screen now, if you guys can just answer that for us. Yeah, and we will then be saying goodbye because we have to rush off. But yeah, guys, if you're still a little bit confused, can we ask you guys to please just rewatch this video? Remember, on the video, you can actually pause and rewind and look at it again, just to make sure that you understand the concept. Because
and just redo the questions again as well. That also helps.
Yeah, it's actually a very easy idea. It's just we've only got 45 or 50 minutes to get through it. So
okay. Right, guys, we actually don't have time for all these questions. You're going to have to make it quick because we do have to rush off. So, Lucanio, please ask your question.
Ma'am, I didn't get you because of the difficulties of the network. I'm sorry.
What did you ask?
I was asking about the people that do not play anything. Is it an event
so
or what?
In this example, they play netball or they don't play netball. So those are the two things.
Yes, ma'am.
So, and that's the sample. We're not worrying about the people who are not in the sample. We're not looking at them. So we took 27 girls, some of them play netball, some of them did not play netball, and that's it.
Oh, okay.